Are you having issues in your production process and you can't quite put your finger on what's causing them? One possible source could be variable gel content in your material or introduced in compounding. Alpha Technologies application engineers have written a paper on this topic. I'm Jason Humble, Vice President of Sales and Marketing for Alpha Technologies, and I'm joined by Rick Hanzlik, our Global Product Manager. Rick has written dozens of papers on rubber compounding and rubber testing. Rick's also a chemical engineer from Cleveland State. Thanks for joining me today, Rick, to talk on this topic.
Happy to be here, Jason. Thank you.
So I gave a big lead up here to what gel might be doing for people or causing in their production process. Tell me, why do you think this is actually a problem?
Well, gel isn't inherently a bad thing. The issue is when it's introduced, it's typically not controlled. It's a byproduct of the polymerization process. So it can make the rubber behave in unpredictable ways. For example, it can make it difficult to flow. So this is going to be very difficult to process if you're extruding, injection molding, whatever you might be doing. In addition, it can lead to very undesirable extrudate. So you're going to get very wavy physical properties, and then it can actually influence the final product properties of the material.
Right, but maybe I jumped ahead a little bit. When you think of gel, how do you describe gel to people? What is a gel?
So gel is areas where the polymer macromolecules cross-link to one another outside of the polymer backbone.
Right. So you have these localized points in the polymer system that are sort of linked together, and they don't flow as you would normally think, right? Or as you would normally expect. And as you mentioned, it's not just the content. So not just having this. It's not a problem you have or don't have, but it's when you see the variability from batch to batch, lot to lot.
Correct. The two cases where it's really going to be an issue is if you have too much of it or if you have variation from batch to batch.
Okay, right. So, however, somebody is observing a symptom of a production problem. We hear this all the time, is that from one batch, product ran great. The next batch, it didn't run well. And not everybody can put their finger on it. So you mentioned a couple of symptoms. What does it look like when someone could be having this problem of variability?
So typically, again, the two things you want to look out for is difficulty flowing. So you might get partial fills of cavities. The other thing would be in an extrusion process, you're going to get a very wavy or bumpy extrudate. So these could be two symptoms of that gel content. And
you mentioned that flow is affected as well. So especially in an extrusion process where you're coming out of the die, you can see changes in die swell, for example, right?
Definitely. And when you're filling a very specially engineered cavity and you have differences in your geometry, these things can be an issue.
Okay. And you can't always, people can't look at a material and say that there's gel in there, right? So it's possible that, as we said in the introduction, this could be a lurking variable. It's something that has changed or that they've introduced into the process, and they don't quite know that. Why don't they really know that what's in there? How are they currently measuring it?
So gel would be very difficult to detect with the naked eye. So a couple methods that people use currently to look for gel. One is using very harsh solvents, wet chemistry, dissolving the rubber sample, and then measuring the remaining precipitate. Another method is gel permutation chromatography, sometimes called GPC. That method's kind of time-consuming, expensive. With the wet chemistry, now you're using kind of dangerous solvents like chloroform or DCl. So now you're using a lab tech or chemist that has to perform this testing. It's a little bit more expensive. It's time consuming. So a lot of people don't bother doing it.
Sure. And I've been in quite a few production facilities, extrusion houses or injection molders. They don't typically have wet chemistry capabilities in my experience, right?
Yeah, in those situations, if they do gel testing, typically what they'll do is extrude a long, thin film of rubber and then visually inspect it with an optical microscope. So this process is very subjective, user to user. So you're not going to get a really solid measurement. It's more of kind of a baseline. It's going to tell you, there might be gel. It's not going to give you a number of what is our gel content.
But that becomes somewhat subjective to the observer then too, right?
Exactly.
And that itself takes quite a bit of time in my experience. So that's what, because those are difficult, people currently aren't really doing that often. The method that's proposed in the paper, and of course the paper is available to download in the video notes as well as on the Alpha website, is to use an RPA for Large Amplitude Oscillatory Shear Rheology, or LAOS for short. I have to say that doesn't sound a whole lot easier. It sounds kind of complicated. So what is LAOS?
So it sounds complicated, but the good news is all the complicated stuff is behind the scenes. Our software engineers at Alpha Technologies have basically done all of the math for you. Mm-hmm. And what this is, it's a new way of testing materials. Typically, RPA or MDR testing is done around 1% or less strain. So that's where the large amplitude comes in here. We're going to be dealing with 500%, maybe 1,000% strain. And what that does is lets us look at the polymer behaving outside of the linear viscoelastic region, in the non-linear viscoelastic region.
Okay, mostly right now we're doing small oscillation. This is a very large deformation of the material that's happening, and so many rheological models are based around that very small oscillation. And so is there, I guess I would say, does the user have to do anything special because now they're using different methods?
So that's a nice thing. Some scientists a lot smarter than me actually, like you mentioned, put together these rheological models and break it down into a base equation. And we can look at what's called the LCB index. And that's the long chain branching index. This is going to give us a ratio of how much kind of gel content there is.
Okay, and LCB index, is that something then, again, I just want to know, does the user have to do any calculus? Because in my experience, people don't like to do calculus after school. So how does the system show somebody what the LCB index is?
So the LCB index will show up just like a variable, just like your MH that everyone's used to on an MDR test. Mm-hmm. You can now add your LCB index variable. And the nice thing there is you can perform all the statistical functions that the software has available, and you can even create a specification around it so that you can monitor your LCB index from batch to batch, from campaign to campaign.
Okay, so for anybody who's looking to get their arms around this and say, I want to establish a baseline, so when you've maybe brought on a new raw material, you could establish a baseline for that raw material and monitor that like you would, as you mentioned, ML, MH, any other variable, correct?
Absolutely.
And then within the enterprise system, for example, there's a statistics module that's available. So do you think that this lends itself to things like statistical process control that someone might, you mentioned there's specifications possibly, so you could establish those over time, for example?
Correct, yes. So like all of your other test results, those are going to be stored in the enterprise system, and you have the ability to do statistical analysis on them, mean, median, mode, standard deviation, coefficient of variation. So you can look at that from run to run, from sample to sample over time, and then you can actually put your specifications in there, and in real time, as those tests are coming off the production line to the lab, you'll get a nice pass or fail based on that baseline that you established.
Yeah, and that's interesting because one of the case studies, the paper has a couple of case studies in it. One of the case studies actually talks about even if you have stability in the raw material, as it ages and maybe as it's exposed to different, we'll say heat histories, if it sits in a hot warehouse or a hot truck, you can actually increase the gel content over time. So one of the case studies was using different stabilizers to inhibit that change in gel with heat, right? So we've probably seen that a number of times where, again, you have this variability. The raw material supplier says nothing changed. So you would expect that if you set up that control system, you would detect that variable gel content, right?
Correct. Yeah, there's a number of different ways that gel can be introduced to the system. Like I mentioned earlier, during the polymerization process, as you just mentioned, aging, and it can also happen during mixing.
So say a little bit more about that, because I think as you walk through the production process, you're looking for all these potential sources of variation. So now you've got the raw material, you've handled it properly, but you're saying that in mixing, as you're processing it, you can create gel?
Correct. So that's really the importance of testing at each stage of the process. So you said the raw material supplier, so you would use this test method as an incoming verification of your raw materials. Then it might sit there for a couple months waiting to be used. So you might want to test it again against that baseline you established to ensure that it's still good. And then once it goes through some of that processing, you would test it again to make sure what that final product is going to process properly.
That sounds like an awful lot of testing, and we told people early on that this was more efficient. So, I mean, what's involved in doing this test then? It's different than an MDR test. We talked about that. How long does this take somebody to do?
This will take about 10 minutes. Okay. And it's different in an MDR test in terms of what's happening in the instrument. It's the same as an MDR test in terms of what the operator has to do. And that is place a 5-gram piece of rubber into the dies and press one button.
Okay, that sounds a little easy.
Yeah.
Okay, so that's easier than I thought. So, and your team, the applications engineering team, our product team is constantly consulting and advising people on how to set these sort of control systems up, correct?
We're actually looking to introduce a customer resource hub that should be launching later this year. And that will allow our customers and users to log directly into this portal and watch self-help videos. And we would have one that they could watch, and it walks them exactly through what's the best practice for creating that baseline. And then in the system, how do you set up that specification and then manage it over time?
Okay, yeah, that's great, because that gets very practical, and I think a lot of times we end up in a very technical realm, and that's important, I think, for people to understand, but also practically, how would I actually implement this to get the benefits from the test method? Well, I think we covered this at length, and I've enjoyed the discussion on it. I would say that anybody who's interested can go to download the paper either from the description here in the video or go directly to Alpha Technologies' website. And for anybody who wants to dive in a little bit deeper to understand the method, our global applications engineering team is always available. And in fact, I think they like talking about this stuff maybe a little too much. Rick, thanks a lot.
Thanks, Jason.
Bye.